Okay, so just to talk a little bit about the kind of the thesis of what we're doing and how we're approaching this. It's a little bit different than I think the other universities in that we're generally doing a 2-semester workshop called parametric precast concrete workshop, and so it's a little bit of a different structure. Though I think a lot of the questions are really the same, and I think that there's a lot of similarities, especially to what they're doing at NC State. I think one of the main kind of questions that we're asking are, or one of the main questions we're asking is, what is the unique affordance of precast, which allows an architect, allows a designer to have a kind of expression or an experience, etc., that one couldn't do in another material? Because as we know, especially if we're talking about structural systems, it could ultimately be a kind of value engineering proposition in terms of how these decisions get made. So we're really trying to ask the question of what's the plastic design potential of precast that allows for something really special and unique to happen. And that's ultimately what's going to keep the building as precast compared to cast in place or timber or steel, et cetera. And we do that through material explorations and advanced technology. So the way it's structured, again, in this kind of 2-semester structure, what we're doing in the first semester, and I'm just going to kind of run through some images of the first semester, it's really all about material exploration, learning about the material, learning about technology. We have a kind of major focus on parametric design and the kind of variability that can be produced with that, both from a kind of theoretical perspective, but also technological perspective, and the students learn all the technology. They learn CNC fabrication and all of that. I guess the only other thing that I would say is that this course is taught directly in our digital fabrication lab at Georgia Tech, which is really a fantastic facility that we have. It's about a 15,000 square foot facility with robots and routers and water jets and all that sort of stuff. Big full-scale stuff, so industrial stuff. So what we do in the fall is we start with the most simple exercise. Make a 6-inch by 6-inch by 6-inch concrete cube. And so and each of the students is working discretely on their own. And so just that really simple, almost ridiculous exercise is transformative for them, just to learn those basic techniques of carpentry, because of course we understand that precast is dependent on other material systems such as carpentry and milling and all that sort of stuff. So just that simple exercise of making a cube and casting it is really kind of eye-opener. And then they transform the cube. So then there's a design operation to transform the cube through some sort of simple parametric operation, and then they have to create a mold. I'm not showing those images. I'm just going to talk about the end of the fall semester. Then they have to create a mold and cast that. And then we worked through a series of material exercises in the fall, and this semester we ended up with our kind of final fall exercise of a decorative privacy screen for a pool, right? So we kind of called the project Flow, and we use Flow as a kind of design generator because it's an interesting concept in just in terms of fluid dynamics and all of that. But how does that start to inform an understanding of concrete as a material which has this sort of transformation in terms of its state from a liquid to a solid state, and what's the design potential there? So I'll just show one project. This was one of our students. Another thing I would say this year was really interesting. We had students at every level, from freshmen in the undergraduate all the way through to PhD students. And so that was really quite interesting, just in terms of the kind of cross-student dialogue that happened. So this student was looking at flows and fabrics and trying to understand the potential of fabrics to make these kind of flowing forms. Of course, we know that fabric form work is really interesting, and of course we're playing with that. We're looking at precedents, etc. We're working with kind of reconfigurable jigs and reconfigurable molds, and looking at the idea of a highly subscribed form versus a form which has more agency. This was actually the PhD student who's working on that question of material agency in design. And so here you can see this rubber mold, which is sort of overlaid on a kind of loose parametric pin mold. and trying to then codify that and make it explicit as a set of instructions, and then trying to parameterize that in Grasshopper. And each step, the design is evolving, right? Because we know that the kind of technological questions are constantly forcing the design to evolve to respond to those questions. So the students come in with a range of technical skills, but we really just assume that they have very little parametric modeling knowledge, or certainly not expertise. And so we take them through a kind of quick workshop in parametric modeling using Rhino Grasshopper, which I think is sort of standard fare at this point. And so this student was really interested in this kind of idea of the stone in the lake, or the kind of ripple effect that could be produced, but how could one study that in a parametric way? And this was the final design. So again, this is kind of midpoint of the overall project. This would be the end of the fall semester. And then we take that design and here again, you can see the parametric variations that are being studied in each one. So we never kind of have a single instance. It's really always about how do we create a system and start to push and pull on that system and look for the design potential. Then of course, we're still in the fall semester here, so then we start milling these out of foam at the DFL. Actually, we ended up milling these at my studio this year because our router was down, but that worked out well. And then we coat them, and we took them up to Athens with Ray and Jorg and cast the rubber, and then bring them back to Georgia Tech and cast them in concrete. So that's, again, I think there's a lot of commonality here, what we're doing, what NC State is doing, and even to some extent what you guys are doing at Clemson, Carlos. So that's kind of the end of the fall. I'll step out of that presentation. So what I thought I would do is really kind of focus on the end result of the spring semester, and also then talk about how we dealt with COVID, because so much of this course is about material thinking, material design, and then ultimately full-scale fabrication. We really had to tack at the end of the day in a big way, and it ended up being quite interesting. So again, they're sort of starting looking at precast, precedents, all of that as a first exercise. And then the project itself, we've done this a couple times now. I think it's a pretty interesting project. We have the students design a precast beach house. And the reason for that is we're trying to give the scale of we're trying to keep the scale of the project small enough so that the students can still be very intimately connected to the material reality of precast and get to the kind of detail scale so that they can then do a full-scale mock-up at the end. But then there are other cultural reasons, right? We know that we have issues of climate change and these sort of catastrophic events that are happening on the coast. Should we even be building on the coast anymore? Well, we know that precast is actually a system that can withstand these sort of forces. It can be built off-site. It can be brought to the site and erected with kind of minimal impact if you do it the right way in terms of erection and all of that, with sort of minimal impact to these pristine areas, and it's resilient. So we thought that this is kind of a really interesting program for the students to work with. We give them a very simple program. So in this case, this year, what we're calling the project the Lighthouse, right? So it's basically a kind of merger of a 5-room boutique hotel and a coastal lighthouse. And so they had to kind of grapple with that. They're given a site. The site is in North Carolina on Bald Head Island. And what I would say is that from an architecture perspective, because this is not a studio, I do explicitly kind of, in some ways, ignore some of the architectural questions that we would ask and really push on in a studio in order to allow the students to really focus on the potential of precast as, what we would call structural envelope or kind of total precast, as the industry would call it. So then in the third exercise, they're, again, working with full-scale mock-ups and all of that. So what we've been able to achieve in the past, this is the kind of end result of a few years ago, where we did build 3 full-scale mock-ups. These are roughly 6 to 8 feet tall, each of them, working with Gate here. We built the molds at DFL and sent the molds to Gate, and they poured them. And then another year, we were invited to exhibit the work at Fab City in Paris, which is a large conference really focused on resilient local urban resilience and how things are made in the future, right? Again, dealing with some of these larger cultural issues. We have this kind of vault that we created out of variable mold system. This is all ductile, so this is all UHPC. The students learned a tremendous amount. And this also goes back to questions of waste, right? How do we produce variation or variability with a single mold type? So each of these was produced with a single rubber mold and different mother molds. So that's what we would have gotten to this year had, you know, COVID not happened. So again, in the spring, they're starting with precedent research. We know all this stuff. I'll sort of skip through this. What I would say, what is interesting about the precedent research in this exercise, in this project, I'm going to show two projects. In this project, there was a kind of obsession with aperture. And so that really informed the design exploration, and I would say ultimately the design system that they came up with. So this relentless kind of inquiry about aperture. And then again, you know, the idea of the lighthouse. So here, aperture became another way of expressing lighthouse. So it wasn't necessarily about having a lantern room at the top of the lighthouse, but how could you make a concrete building porous, almost like a lantern? So they're looking at lots of different options. I'll sort of skip through this. Really what I want to get to at the end is how we tacked in terms of the mock-ups. So they started to develop this sort of hyperbolic aperture and looking at it in different scales, you know, what happens at a kind of mega panel versus a medium size versus a small, so it's a sort of SML project. They started to look at that in aggregate to try to understand what the potential was, understanding that, you know, you could go floor to floor or you could half that and sort of have a double or a quadruple, et cetera. And then what I thought was really clever, they started to say, well, what happens when we start to mix this up? What happens when we shuffle and we start to put, you know, different scales together? There's really this incredibly, some people really don't like this project, in fact, because it's kind of schizophrenic, but there's this incredible kind of scalar ambiguity that happens, which I think is really quite interesting. You know, that would be difficult to do in steel, right? We know that we can produce 3 types of molds and cast those all day, but in steel, that would be quite difficult to do because of the complexity of form if you had to produce it each time as a panel. Then, of course, you know, they're doing all the parametric stuff. I won't bore you guys. I think we all know about that. And then looking at these sort of slots that produce an even stronger orientation of light. And, you know, they were doing some site analysis, again, all of that. I won't focus on the architectural details. I think they're producing quite interesting drawings as well. Representation is always very important for us. Again, how do we draw? How do we convince people that these projects are exciting and that precast is the right material for it? So this project was actually a reasonable architectural solution, I would say, but all of them are really undercooked relative to kind of planned section development. So then, you know, COVID hits. So we were supposed to build full-scale mock-ups. COVID hit, so we said, okay, how do we deal with that? Well, let's just have the students, rather than working as a team of 3 for each project, let's have them each do their own take on how to do a set of detailed shop drawings and develop a method of making that panel as a virtual exercise or a virtual mock-up. So each of the students, so basically what you're going to see is 3 variations of how to design and draw a process of fabrication. So for me as a faculty member, and also just in terms of design research, that was really interesting to see 3 different takes on what was originally a group project. I'm going to go through these quickly. I know we have limited time. And so they ultimately would have produced these panels as full-scale mock-ups to install at the Hinman Courtyard at Georgia Tech. You can see the real mock-ups back here, and then our kind of virtual mock-up here. Any questions while I flip through this? I'm just going to kind of flip through some drawings to share some of our graphics. We're all visual people. So, you know, again, they're looking at sort of 2-way coffer rib systems and how do you skin that and all that. We do a lot of this sort of work both at Georgia Tech and I do a lot of it professionally as well. So that was just one student's take. So here's the second student's take. Sometimes they're very similar, sometimes they're quite unique. I would say in this project, the 3 variations of the students were rather similar in terms of their approach. In the next project, we'll see really quite radically different approaches to making something as simple as a twisted fin. Okay, so the next project, you know, if what we saw in the first one was pushing precast from a kind of obsession about aperture, the next project is really thinking about kind of environmental forces and aerodynamics, and also then again thinking about the typology of the lighthouse and the kind of formal languages that those lighthouses have. So they did a lot of research on lighthouses within the vicinity. I won't harp on this stuff. And so then they started looking at aerodynamics and the kind of, you know, could the actual performance of the building start to inform whether it does or doesn't, whether it would actually work or not, could at least as an analog and as a process, could it start to inform the overall form of the building? So they're looking at flows and cylinders and twists and all of that. They're looking at, you know, other projects that they found interesting. And then ultimately, this precedent became probably the most important in terms of creating this kind of gill in terms of it's sort of a reference to fish, gill fin system, which could allow for moments of light and view, also air to penetrate through the building, but also a kind of idea about a structural enclosure. So they're, you know, generating all these parametric permutations in Grasshopper, and then developing a kind of what we call a thin model, a kind of surface model, to start to study formal variations, and then starting to push that into a thick model that actually has thickness and starts to resolve connections and all of that. I think this project probably failed the most in terms of how the vertical element meets the horizontal element at the slab, but that's a conversation for another day. But the students did a really good job in terms of starting to think through and maybe we're not supposed to say this now, but the reality is buildings are complex and they're made of different materials, and we have to think about how one material connects to another. So they really started to think about those kind of details of how one material would connect to another. So this is kind of still aperture that the panels would hang on. How am I doing on time, Peter? Okay, so this is sort of wrapping up. So this is basically the three variations of how they would produce these twisting panels. Again, the idea here is that these are very thin, like on the order of 3 inches. I think we talked about them maybe being UHPC. We're not really sure. This would be this would be a challenging project, in fact, in rubber. That's, you know, whenever we see a complex thing, we say rubber, and we love Ray, and we love US Formliner, of course, and we love Reckitt. But some things are quite difficult to do in rubber. And I think this one, because it would really need to be poured vertically, would be quite a challenge. So we said, okay, we actually said you can't go to the default solution of rubber. You have to really think about how this would be poured as a vertical, conventional, actually, coffered system. Okay, so these are the kind of virtual mock-ups. This is Christian's work. Christian's really a powerhouse. He's only a sophomore, which gives me great hope. Looking at these kind of detailed dimension drawings of the mock-up. And again, just to clarify, so really now they're making shop drawings of the mock-up. Looking at embeds, thinking through the erection process. And then looking at the form. So how would they actually make the form? This mold was really complex because it's twisting more than 90 degrees. And so the interlock of the mold is a real challenge. So they ultimately had to kind of break this up like a kind of Japanese joinery or a kind of puzzle to think through how you would not only mold it and pour it, but how you would demold it. So here, this student was, again, very clever and looked at sort of tangency issues at the corners to be able to subdivide the mold based on those tangency release parameters, if you will. Again, we pushed drawing representation. Since we weren't going to make a physical thing, we wanted to make beautiful drawings. So that was one student. This is another student's take. Again, what I thought was really clever that Rana did here, she used a parametric algorithm to come up with the subdivision of the mold, to study the geometry and the issues of undercut and, you know, interlock and all of that. And she did a really great job. So they really did have to build the mock-up, right? They just had to build it through drawings. This is a beautiful drawing here. And maybe this is the last one. I'll kind of wrap it up there and maybe open it up to questions. Again, even thinking through, the coil rod inserts and how do you lift, how do you hide that coil rod insert on a thing that's exposed 360 around all of its faces and all of that. Okay, I'll leave it there, Peter.
And I'll say, having been part of that design review, students did an amazing job, and I think the critical thing was they lacked the producer input at that point, because that would have been very constructive for both the students and the producers, I think, to see how these designers were thinking and how do they actually get into the making process. So
agreed, and I'll take one on the chin there. I think this is all happening right as we're adjusting, and I probably let some of those things go just because we were all trying to stay afloat. So it's great. It's a great point.
It was new times for us all. So
yeah. No, I think
I know a couple of the professors participated in that final design review. Carlos was on there. Charles Jones from
Tulane
was on as well. And I think we had a few producers as well. So any questions, any discussion on what Georgia Tech was doing?
Okay.
So Tristan, I have a quick question, if you guys can hear me.
Yes.
It looks like you did yours through multiple semesters. Did you have similar students, or did you have to strategize how to parcel off and break it down into different semesters in terms of the workshop, going from one to the next?
No, that was an explicit requirement. Obviously, you can't really require it, but you just make it very clear to the students at the beginning of the fall that the expectation is that this is a year-long project. And this was an elective course, right? I mean, we get good subscription typically, anywhere from I would say on average 10. Most years. This year I think we had 7. This year, no, we ended up having 9. But you just tell them at the beginning, and because they're so excited, we typically keep most of the students in the second semester. Maybe one will drop out for whatever reason, and we'll pick one up. We don't. The other piece to that that's complex is that we don't say in the spring, if somebody wants to join because they couldn't be with us in the fall, we don't say no just because they weren't part of it in the fall. We say you're going to come on, and of course you're going to miss some things, but you're also going to learn through the interaction with the teams. And so it becomes a very organic, symbiotic kind of learning environment, because you learn through doing, and because so much of this is about making. The students, even the ones that joined in the spring, they really have a pretty rich experience, I would say, in the course. But no, we make it explicit. This is a year-long project, and they, they're into it.
I think you did have 1 or 2 new students in the second semester, didn't you?
Yeah, in general we do. In general, we might lose 1 in the fall, and then we pick up 2 in the spring. Because there's a buzz that happens in the fall. People get excited about it, and then they want to join. And you guys know as well as anyone that these students are under so much pressure from coursework that a lot of times it's just they can't do a full. They can't fully commit to a full year, and if they can't, we just don't want to limit them in the spring if we can take them.
Can you get some of these students to register for Project Precast next year? Because some of this work is great.
Well, we won't have these students, but we can certainly have.
Oh, you said one of them was a sophomore.
Yeah, but you can't take the same course and get credit for it twice.
Yeah, but he can still come to Project
They can come to
Precast.
convention, and they can apply for Project Precast.
He can still apply to Project Precast.
Absolutely we can. That's true. I didn't think about it. Sure.
So that's a communication thing with our past students to make sure that Marty has email addresses of past students so that she can advertise that.
Yeah, and Marty, you'll get this. I think I gave you the midterm report. You'll get this full report, and I'll give you.
Okay.